Hi all, I am Dr. Prathiba, working as an Associate Professor in the Department of Electronics and Communication Engineering, Kamaraj College of Engineering and Technology. Today let us see about Verilog HDL, Hardware Descriptive Language. The overall content what we are going to cover today is what is Verilog HDL and the basics and the types of Verilog, also the different types of operators which are present in Verilog coding, and gate level modeling, what are the primitives are being present in this particular modeling, and the last one is a basic how to write a Verilog basic programming using gate level modeling. What is Verilog code? Verilog is a hardware descriptive language that is used to realize the digital circuits through codes. In Verilog HDL, we commonly use to design for RTL. RTL is nothing but register transfer level, and it is used for verification, the test benches which has been developed for the particular digital circuits. Mainly this focuses on the two concept for designing process of using your FPGA as well as for the ASIC. So, this is the main thing why we go for Verilog. There are different types of Verilog codes which have been present. The main type is, it starts from the low level abstraction to the high level abstraction. The low level abstraction is nothing but gate level modeling, and the high level abstraction is nothing but the behavior level modeling. The gate level modeling is also named as structural modeling, and we have another one more type of modeling which is called as a data flow modeling. The important points when you are writing a code using a Verilog. So, the basic one is, it is a consist of modules which each module will be representing for the particular digital circuit solution, and this module will contain the module as well as a end module to close the module circuit. And the next one is, there are different types of data types have been present. Basically registers and wires will be used in terms of data types, and there will have n number of ports, have different types of operators followed for the logical, arithmetic, and also for the bitwise operations. Then the most important thing is, this Verilog code can be executed in terms of parallel or in terms of sequential manner. So, this will make the processing very fast when we do it in a parallel form. So, when you come for the basics of Verilog coding, we have to mainly focus on how to write the program. The first initial step is, we have to start with the module and followed by the module name, and then we have to give the list of ports which are being present. Ports are nothing but your inputs and the outputs, and followed by the declaration. So, in here you have to declare what are the variables are used for your input and what are the variables are declared for your output. After declaration, we will go for the local net declaration also, and then we can have n number of statements for our execution, and followed with the end module. So, whenever we start a module, we have to close it with an end module. So, this is a basic rule of writing your Verilog code. See the bitwise operator which is present in Verilog code. The first one is negation, which is nothing but the tilt symbol, and the second one is an and is being represented by ampersand, and or it a straight line, and XR is a cap, and shifting A left by B bit, which is nothing but A less than B, and shifting A right by B bit, which is nothing but A greater than B. So, these are the bitwise operators which are present in the Verilog code. There are basic arithmetic operators are present in this Verilog code. One is an addition, which is a plus symbol, and subtraction minus symbol, and multiplication asterisk, and division slash, and modulus with percentage. Operator which is called as a logical operator. Wherever we do if then else conditions, we also go for this operators. Negation, which is an exclamatory, and which is nothing but double ampersand symbol, and or is double straight line. So, these are the different types of operators which are present in Verilog codes. Other operators which are present in Verilog codes are equal, double equal to symbol, and not equal, exclamatory equal to, and less than symbol, and greater than symbol, less than or equal to, less than symbol followed by equivalent to, and greater than or equal to, which is nothing but greater than or equal to symbol. Coming to the gate level modeling, first initially we want to know the symbol of the gates. So, these are the basic gates which have been available, like basic gates like AND, OR, and NOT. So, coming to this one, it has n number of inputs and one single output. Coming to AND and OR, so we can have 2 inputs of AND, 3 inputs of AND, 3 or 4 or n number of inputs can be decided for your AND and OR. For NOT, nothing but an single input and single output. This is a symbol representation of the basic gate of AND, OR, and NOT. The next one is NAND universal gate, which is nothing but NAND and NOR gate. The symbol representation is given here for a 2-bit NAND and NOR, and followed by we are having an XR gate, XNOR gate, and the last one is a buffer. So, the difference between an inverter and a buffer is, the buffer is nothing but whatever the input is given here, that it will fetch to the output. But coming to the NOT gate, that is inverter, whatever the input is given, the complement of the input will be fetched to the output. We already I have pointed in the previous one, there can be n number of inputs and one single output. So, basically there are these are called as the primitives, and coming to the primitives we have AND primitive, NAND primitive, OR, NOR, XR, XNOR, buffer and a NOT. So, these are the basic primitives which are available for gate level modeling process. So, here it is nothing but it can have more than 2 inputs and one single output. That is what we have represented here. But when we come for the buffer as well as when you come for the NOT gate, I have pointed earlier itself, it is a single input and it can have multiple single output or multiple output. Let us see an example for basic gates using a Verilog code. So, we are taking an AND gate here. I am taking a 2 input AND gate, A and B is my input and Y is my output. Now, we have to start writing the code. So, as we have pointed earlier, the first one is we have to write the module. Module is a keyword followed by the module name. Whatever name you are going to give it for your circuit, you can give it as it is. So, I am taking this is a basic gate. So, I am taking AND example. Here we have to be very much clear because there are different types of keywords are being present when you are using the gate level modeling. As we know, the keywords are AND, OR, NOT, NAND, NOR, XR, XNOR. So, we have to be very clear that we must not use this keyword as your module name. So, whenever we are using the keyword as your module name, there will be an error while you are executing. So, I can take it in a separate way, that is why I have written AND example, that is why EX, followed by what are the ports are being available, what is the input port as well as output port. So, I am declaring my output is my Y is my output port, A and B is my input port. Then you have to complete it by the semicolon. Next one, I have to declare what is my input and what is my output. So, my input is a keyword, input, A and B are my inputs. So, I am writing A and B. Next, output is only Y. So, I am giving output Y. Since these A, B and C are having only a single bit, I no need to have a bit representation, because when a variable is being declared, it will assume that it is a single bit. Right. So, next one, what type of operation is being done? We are using an AND gate. So, for a gate level modeling, the keyword is AND, and I am writing this one as my G1 gate. This is a label. So, G1 followed by output comma input. Output is Y followed by the input variable. And now we have set the operation. So, what the purpose of using this one is, it will perform as an AND gate. So, we have completed the program. So, I am closing with the end module statement. So, here it should not be ended with a semicolon. So, we have to be very clear when we are writing the end module. So, the similar process can be done for all the rest of the basic gates like AND, OR, NOR, XR, XNOR, every gate. Thank you all.